Hello students, in this video lecture we will discuss about the course Wireless Networks 19EC 507, where we are going to focus mainly on the cellular evolution from 3G to 4G, and we'll discuss about the long-term evolution and its architecture. The course outcome of 4th unit of the course Wireless Networks is to write about 3G networks, its protocols and applications. So let us move on quickly. So let us first discuss about the cellular evolution, which began from the first generation till the third and fourth generations. So when we just observe this diagram closely, we will be able to spot GSM standard as well as HSPS standard, which are the most popular wireless standards for mobile devices as well as the data terminals. So when we comment on these two, they are mainly used to increase the capacity and also the speed, where they try to deploy a different radio interface along with the core network, right? And then there was a gradual shift to the long-term evolution, and the devices that supported both GSM and UMTS networks and CDMA 2000 networks can use the CLTE frequencies and the bands in different countries. Also, the multi-band phones are the only ones that can use LTE frequencies and the bands in all countries where it is supported. Okay. Then talking about the evolution towards higher data rate, the mobile phones and the data terminals which try to make use of the LTE are subjected to high-speed data transmission standards. So this actually resulted in increased capacity and increased speed. We also tried to simplify the core network architecture by deploying different radio interfacing methods here. So we can very well observe you have the GPRS over edge around the ranges of kbps, and then you had WCDMA followed by HSDPA, and then 3GPP followed by WiMAX, and then CDMA 2000, and slowly the standard 3GPP evolved towards the long-term evolution. Yes, so this typical diagram shows the shift from 2G to 3G, where we had a better data rate, and a gradual shift from third generation to the fourth generation system. So what is LTE? So let us focus in detail about the architecture of the long-term evolution. So observe this diagram. We have MME, HSS, and then a serving gateway, PDN gateway, and the node Bs and several interfaces. Let us look into each and every module in detail now. So focusing upon the LTE architecture, there are three key components here. So the first one is the user equipment UE. So user equipment UE, and then you have the second important key component is UTRAN, which we have already discussed in the previous class. It is Evolved UMTS Terrestrial Radio Access Network, and the third important component in the LTE architecture is Evolved Packet Core, EPC. And we also have different interfaces. So it is denoted by the notations here. U suffix U, you have it is X2 and then X1. So these are all the interface standards deployed. So what are all the important feature or the functionality of this UE or the user equipment? So when we talk about the user equipment, all communication functions are handled by our mobile terminal. So the other name for user equipment is nothing but our mobile terminal, and this helps us to handle all types of communications. The data streams are terminated here, as well as the SIM card for our LTE equipment is controlled in this particular unit, which is known as the Universal Integrated Circuit Card. So the next key component is about the UTRAN. So what is UTRAN? So it is a radio access network which is nothing but it replaces the functionality of UMTS, HSTPA and HSUPA. This deploys a new air interface system with higher data rate, low latency, and this is providing optimized output for the packet data transmission. And when we talk about the nodes here, EBN nodes, they perform two main roles in this architecture. They try to send and receive the radio signals to and from all the mobile devices, as well as this sends handover commands to all of its mobiles at a low level, controlling their operation here. The third key component which we have discussed under LTE architecture is about the evolved packet core, which is the core network actually. Commenting on the key functions of this EPC, Evolved Packet Core. So when we comment on this, you have a central database to be maintained in this core network architecture. And this central database contains all the information about the network operator's subscribers. And this is in fact known as the home subscriber server. So this information is carried over the UMTS and GSM. And this is located inside the HSS component. And then we have the other terminal called SG, which is used to communicate with the outside world, where we communicate in terms of packet data, right? So you have packet data networks in which the packet gateway is located. Also, the switching gateway acts as a router between the base station and these PDN networks. PDN is packet data network. We also have a mobile network operator, and this mobile network operator is the highest level control entity is nothing but our HSS component. So HSS is home subscriber server, and this helps us to control the mobile's high level operation throughout the signaling process. Then we have the component mobility management entity called MME. So this is one of the control entity which is responsible for all control operations. And then you have the serving gateway, this SGW, which is, as I said earlier, this is acting as a router between the base station and the PDN. And PDN gateway, there is a component called PDN gateway, which is helping us to terminate the SGI interface towards the PDN. And this is in fact responsible for all the IP packet based operations like deep packet inspection, UE IP address allocation, as well as the transport level packet marketing. Then we have our HSS component. So as I said, this is actually acting as a central database which is containing user related and subscription related informations. Yes. So these are all the big points about LTE. So this LTE is actually a successor technology, not only to UMTS but also for CDMA 2000, as we discussed in the first slide, where we had an evolution diagram, right? And this is important because this greatly improves the system performance, like 50 times performance improvement and much better spectral efficiency compared to the other cellular networks. And this in fact introduced us to higher data rates, specifically around 300 Mbps peak downlink and 75 Mbps peak uplink. And this serves as an ideal technology to support high data rates for services like VoIP, voice over IP, streaming multimedia without any hindrance, video conferencing without even a single hitch, or even a high-speed cellular modem. And this LTE deploys both TDD as well as FDD, frequency division duplex, as well as time division duplex mode. So now, after the discussion of LTE architecture, let us now spot out the major advantages of LTE. So this system offers a very high throughput because we have high data rate in both downlink as well as in uplink. Then this is a low latency system. we try to deploy both the mode of operation like FDD and TDD in the same platform. This offers a superior end user experience, which is giving us an optimized signaling for connection establishment. Also, it offers a seamless connection. Then it is a simple plug and play technology where the user doesn't have to manually install all the drivers for the device. So these are all the significant features, or in fact the advantages of long-term evolution. So with this, we'll end the discussion on the topic LTE. Thank you.